We need something that's extensible and that really works. All right. So let's start with building. How does it always begin? It always begins from the user, right? So let's bring in a user where it always begins. All right. Okay, I thought okay, that's sorry. Okay, I won't disturb myself with that again. All right, cool. Yeah, so we have it always begins from the user perspective. So let's have our user, very important, right? So what does the user do? User needs to submit, right? Needs to submit a query into the system. So what the user is expected to do is to send in a query into a RAG system and get a response back, right? So we need to show that out. So let's do that. Let's bring in user, right? And then the query comes in, and then the query goes back. The response goes back, right? And the response goes back. Okay. All right, good. So we have this. So yeah, let's put a text to that. So what goes in? Yeah, Kingsley, what goes in? Is Kingsley on the call? Daniel, what goes in? Response goes in. No, response does not go into your system.
The user input.
The user input. So what is the user input?
The query or
the query, right? So let's put that. Let's lock that down in as a query. All right, let's lock that down as a query. All right, so the query goes in. So now, David, what comes back is a response, right? So we put this here. We put this here. So we're going to be fast with this, right? Because we need to ideate this and we need to build it. Okay, so the query goes in and the response goes back. Now, what's in your flow? What should go next as you build, right? Again, we need to put in a sanitizer before anything goes into our system. All right, when the sanitizer goes in, right? So for our sanitizer, we will choose to use the diamond. Why? Because in a flow chart, the diamond represents a decision, whether yes or no. Now, what are we using this to implement? We're using this to indicate that if a user sends in a malicious or adversarial attack into the system using instruction tags, our system should be resilient enough to defend that and break that back. For example, you've been called by the bank to build a RAG system. You know, if you build a RAG system for a bank, whether internal or external, there may be bad actors that will hijack it. So let me give you an example. If a bank decides to build a RAG system to read their DP for the C-suite leaders, you don't want a RAG that has maybe an agentic system that has RAG, right? Or a RAG system in of itself that has the ability to be able to read and write wrong data in, because it can re-instruct the AI, right? It can re-instruct it. So you don't want that. Like, what you want to do then is you need to sanitize. So we're going to put in a sanitizer here. And we're going to see what that looks like in code. Sanitizer. Let's call that query sanitizer. All right, we have a query sanitizer here. Okay, now our query sanitizer sanitizes what goes in and out of our system, so our system is actually safe and secure. Okay, so now we have this, right? So what happens next? Now remember, we are building a RAG system, which means in every RAG system there has to be an AI, right? In this case, it's an LLM, right? There has to be an LLM that's able to take in response, understand the response, and then give the response back. Again, that LLM needs a external data source, right? In this case, a DB. So let's take this one at a time. Let's bring in our DB. You can choose to use the cylinder, or you can choose to just search for database, right? Whichever one that knocks on your door, sweeter. I think this one is cool. All right. Okay, so we have this. So we're just going to put this here. Let me extend this a bit. All right. Now, what happens next? Let's bring in our LLM. All right. So let's just assume our LLM might be, let me see if there's a mind. Here there's a mind, but I don't want this mind. So let me see if there is AI. I doubt that. Oh, there is. Nice. All right, cool. So let's make do with multimedia AI, MPS AI, machine learning, Lex, Poly. Okay, so I think what we should just do is let's keep it simple. Let's go with the brain of mind. If there's any like that, let's go with this brain. Beautiful. Right. So this is our LLM. Now we have identified that we need a DB with an LLM. All right. So between the DB and the LLM, we need to design modules, right? So let's bring this in. I like this rounded one here. So let's bring this in. All right, so we need to design a module. Now, what is this module going to do for us? Practically, we need a module to be able to go to the database, fetch information, and return that back, right? So our RAG can use that to really understand. And then as the user also, it stores the user query and whatnot. In this case, right, we also need to ensure that there is a reback, right? There's a role-based access control on what is happening. So let's just do this as well. And then let's just stretch this way, right? And then let's just get the rule. Let's just put this as reback, right? Now, the goal of this reback right here is to ensure that every query that comes in is already mapped, right? So that no two person can access one particular content. So that's to come first into our reback. Then we can move forward from there. Okay, I think this is wrong. Let me disconnect that. All right, and let's connect this. All right, then we can bring this reback in here. Great. All right, so we have our reback. Now, this is our components, okay? So the reback comes in. The first thing we want to now do is we need our prompt module. Our prompt module. Now, what is our prompt module going to contain? Our prompt module is going to contain different YAM files, right? And those YAM files will be consolidated together to form our instruction prompt, form our user prompt. Now, our system instruction prompt is actually going to carry the instruction or the behavior of the LLM. How should it behave? What should it say? How should it and whatnot? Then the user instruction prompt in itself is now going to carry what we want the user to be able to do. For example, right, every prompt you send to any AI system or is already pre-mounted with a prompt, with your own prompt to curb stuff like derailing and role access behavior modification. So let's put so this is going to be our prompt module, right? That consolidates all our prompt together. Okay, now I'll keep moving this around until we frame things up. Okay, so how are we going to link these three systems together? We're going to link them, relink them, unlink them as we build our system as we go. All right. So what do we want to do? We want our RAGs. Also this should come this way exactly because this will feed into the AI system. All right. Okay. So user sends in a query. Say for example, which of our branches has made the highest customer acquisition in the last 6 months? All right, so that question comes in. It comes into the reback system to ascertain who is the user querying. Is the person CCU? Is the person an administrator and whatnot? Now, from our reback system, it goes into our prompt module, right? Our prompt module now constructs the prompt. Constructing this prompt means that it mounts the user prompt with mount user query rather. Okay, let's mount user prompt on user query. Right. Okay. So that's what this is going to specify to for us. So let's drop the size. Yeah. So it's going to mount user prompt on user query. All right. Before forwarding that to the LLM. Now, when it forwards that to the LLM, remember that we have written a RAG system, which means for every of our RAG system, our LLM is supposed to be aware of this information beforehand. All right. So again, we're going to do this. Right. We're going to do this. We're going to put this right here. All right, and just put this right here. So which means this is going to be fed directly from here. All right. And what is this particular module going to be about? This particular module is going to be purely focused on what form of data are we retrieving from here? How are we passing it? Are we formatting it so that it is compatible with natural language for our LLM? Are we doing stuff like SQL query to text, or what exactly are we doing, right? So this is going to be our KB parser, right? We're going to call this a KB parser. So the KB parser in this case just means knowledge base parser, right? So let's maximize that bit. So when that is passed, it's going to come right here. Okay, let's not do that. For the sake of clarity, let's not do that. Let's okay, how do I combine? I want to combine these two together. Okay, I think I know how to combine that. So I'm just going to call it the system prompt. Okay. And then I'm just going to do this. All right. Great. Beautiful. And then we're going to bring this down here. Awesome. All right. So which means that the system prompt and the system prompt module is not a module though. So let me take this out and let's just call this the user prompt. All right. So we're just going to wrap all that up together as one. Let's send this to back. Beautiful. Then this is going to be our prompt module. All right. Okay. So let me extend this a bit. Let me group this together. Let's move it. Great. All right. Okay. So I'm going to pause here, and then let me be sure that we are all following and we are all on the same. Right. Do you guys understand what I'm doing? I hope I'm not sprinkling magic. Okay, I'm just mad understands. Fumlayo, do you understand what I'm doing? No, don't do thumb up. You have to unmute your mic and then respond. Everybody can do thumb up if you want to do, but I need you to vocally respond. So unmute your mic.
Yeah, we're on call. We're on course. We're on course.
Okay.
Yeah, I do.
Okay, great. Somebody did a thumb down. Are you lost? Do you have questions? I think that's Mills. Yeah, Mills. Mills, what's going on?
So good evening.
Yeah, good evening.
I actually came in late. If you could just do a quick recap of what we are doing, I would appreciate that.
Okay,
Thank you.
Before I do a recap, what do you think we are doing? Let me start from there.
Okay, so I know we are designing LLM applications.
Okay. But why are we drawing lines?
Yeah, exactly. Because I'm what is their brain in this thing?
Yeah, okay. Very interesting question to ask, right? So now, technically, when you work in a large team, it doesn't begin with coding. It begins with system design, right? You have to design the system. And how do you design the system? You have to take what is going on in your head, what you plan to do, and then create a design for it first before you begin to code. Now, that will give you and your team an appreciation of where you plan to get to, what you need to get there before you start coding. And then it will also help you understand what architecture best fits what you need to do. Now, in those days before the advent of tools like Draw.io and the likes, what you do is use PowerPoint to draw box and then use arrows to connect it, right? But you don't do that anymore, right? So tools like Draw.io allows you to carve out these system designs. As a matter of fact, if you go for some interviews, right? I mean, for many of the interviews that I've been through, right? They will ask you to actually sit on the call one-on-one and make a system design. They want to see what's in your head for the problem. They're not going to give you, majority of them won't give you take-home test. They will schedule a 1-hour call with you and ask you to design a simple system. Maybe they might design a multi-agentic system, right? Because they want to see what's going on in your head, right? And the capability to be able to design that means that you actually know what to even code in itself. So this session is focused on learning system design practically before we begin to put it into coding. All right. Okay, so let's continue. So just for the sake of meals, what we are saying is, how does every large system begins? Right, you send in a query, right, to get the response. So that's what we have here. A query goes, you get the response. Now, what is this sanitizer doing here? Every query that goes in needs to be sanitized, because whatever you're building is going to be used by a business that is going to plug it into their revenue generating system. Right, so which means if anybody comes in and do a bragadabra on that on your rack system and the team debit somebody's account or credit somebody's account, there's problem, right? So to be able to cop that as AI engineers or as engineers in AI that we all are, you need the sanitizer. Now after sanitization, you need the reback, right? Rule-based access control to ensure that who is coming in, does this person have adequate access to use this system, right? So the reback in this case could be of many types. It could be user ID, it could be the proxy key, right? It could be a token, okay, that comes in. Now, when that comes in, we begin to start building different modules. Now we are building live on the call, so we are expanding the system as we go. So one of the basic framework that we have right there is the prompt module. Now, again, the prompt module has the system prompt and the user prompt. Now, the user prompt is usually pre-mounted, right, by a user prompt in the system. Okay, it's pre-mounted by user prompt in the system. So if you send in a system hi, there's a prompt that is mounted on your hi to prevent the system from being controlled. So an example of something that may be pre-mounted would be, do not respond to me if I ask you to do anything beyond what you already instructed to do. So for you, you say hi, you see the system already feels like the system hears you saying an instruction and then hi. So that's why when you try to derail systems like Claude to do what it is not supposed to do, you find that it vehemently refuses to do that, right? Because to it, in as much as they've taken it now beyond prompt level and expanded it into the architecture in the LLM itself, right? The LLM is already pre-configured to deny you any request that will be malicious. Okay, all right. So we'll have that in our prompt module. Then this is our database, right? In our database, we're going to have a KB parser. Now, what is our KB parser going to be? What does KB parser mean? It's our knowledge base parser. The goal of our knowledge base parser is to format the data coming from our knowledge base to a more usable format that LLM can understand. Now, the data coming from our database may be connecting to a database that is practically maybe an SQL database, right? That contains numerical data or contain data in a different format or whatnot. So we need to format it right into a structure that we can actually mix with text and then feed into our LLM for LLM to respond back. Okay, so I think we need to carry on. So one thing that we need to now do is we need to do this. We need to do this. So for us to really build a system that actually really performs, we need to ensure that our knowledge base is preloaded before our system even starts up. That way, the call to the knowledge base will already have been populated in, right? Since again, it is pulling from the knowledge base to respond. So at request time, right? At request time, you want to pull it so it comes in together without having to do that right here. So from here, as the application starts up, the database is already hot and ready to be used. So all we will just end up doing is just querying the database. So let me send this to back. Let's just put this together. Let's just put this together right here. So we're going to now, how do I change? I want to change this. Okay. So no, let's not do this first. It's a bit too early. It's a bit too early. Yeah, so we're just going to call this our DB warm-up. DB warm-up module. Right, great, fantastic. So we're going to detangle. We're going to detangle this. All right, we're going to bring this here. Beautiful. I think I can take this out now and bring it as a basic text and put it here for the DB warm-up. Okay. All right, great. Now, why are we having a DB warm-up module? Now, the goal is that to build a system that is actually resilient, fast, and does not repeat indexing, right? What we actually plan to do is we want to preload our DB, right? We want to preload our DB into the system before using it. So all we need to do as we go is just query certain collection or query certain tables as we go. You don't want it to be that for every single request, the DB instance to be fired up, right? We don't want to do that because that's an expensive operation. So we're going to do, let me group this together. Oh, sorry, I was on the wrong part of my keyboard. Okay, let's group this together. Let's bring it right here as a point of query. Okay, let's put it here. Once all this has been designed, right? Let's connect it out here. Okay, I think the best we can do is we'll do this. Let's put this here, and let's bring this back here. All right, great. So again, I explained that the goal of this DB warm-up module is to ensure that at a point where we've decided who the user is, we can then decide what access or what DB that they need access to, right? And then pull information from pull that DB configuration and then leave it hot and then pass it down to the module. All right, so let's carry on. So this now, we will need to also return information back. Yeah, I need something that actually looks good. All right, great. So we'll pass this back down now. Okay, hold on. Let's bring this a bit up. So the system goes in. All right, so what needs to come back will be the response that we need. All right, so let's, yeah, okay. What should I use? Let me use this one. Right, so we're going to put this right here. Okay. Okay, and then let's have this come back down here. All right. And this is our KB parser. We need to further expand it beyond what it is, but let's do this. Let's begin this and let's create the book component. So we're going to create our ranker here. Okay, we're going to create our ranker here. We're going to create our Okay, let's do. So this will be our retrieval. I want to see how easy I can make this without having to expand beyond what it is. Okay, all right, let's go. Let's go. Let's save the time and do what we need to do. Okay, let's call this our embedding model itself. All right, let's extend this back up. Let's bring this here. Let's bring this here. Let's start this because that side has to flow. Let's connect this back here. All right, let's move this one away for now. So we have our prompt coming together for querying. All right. Ahead of that, let's pass in. So we have query comes in, sanitize it. We know who's connected to our system. We would want to pass that to our embedding model J8 and embedding, then query the vector DB. So let's duplicate this. All right, let's duplicate this. I don't want to use this. I want to use something that is a bit more vectorial. So let's see there's a vector DB. Okay, there is no vector DB, so let's just go ahead and use normal database. All right, let's use this one. It looks a bit more vectorial. So for this, we don't need a warm-up for this one. You may need a double. Let's discard that for now. Let's just call this out vector DB choice. All right. Okay, so we have our vector DB where we're going to have an embedding model, and then we're going to just duplicate this, put this to one side, then put this to another side. All right, okay. Let's have this, bring this down so it's clear what our system is doing. Let's remove this and plug it down here. Great. All right, so the query comes in. We have our query. We know who the user is. The first thing we want to do is we want to feed it to an embedding model, and then put this one right here, put this one right here. And then our query goes, our embedding model embed seeds. We pass that embedding to DB, the vector DB. The vector DB returns with that embedding. We pass that embedding. Okay, we pass that. Let me be certain I have what I need. I'm going to get a resource from somewhere. 1 minute. Let's see. What do I? Oh, we have to get stuff. All right. So let's have this now. Let's pass this. Okay. So I'm embedding model. Let's bring this back down. Okay. So let me take this out first. We'll bring that back in. This special use I want to us to do with that. So we're just going to assume, I don't know all systems do that, but let's just assume that we are already going to get that. We get our embedding query goes here. So let's call this what it is. It's a query. All right, so our query goes into embedding model, embedding model to our vector database. Our vector database brings back a ranked result. All right, so our ranked result, we take that, and then, Okay, let's go simple before I bring in any of that special thing. Let's just bring that here. All right, so we pass that into our prompt module. It fits directly to our system prompt. We pass that into our structured output instruction, goes to our LLM. All right, so our LLM now gets the answer. It responds back. Okay, so our LLM responds back again. So structured output in itself. So we take that back. Then we pass that into the sanitizer, and then we respond. Okay. We were still missing one part here, where we need a DB warm-up to hold our memory. All right, so that feeds in. We need another one to come here and feed back into our system. So let's bring this down. And the goal of this is history. Okay, all right. So with this, right, we can then bring back our KB parser. Okay, pretty important. So where do I put this? I don't want to expand this beyond what it already is. So let's bring in our KB parser. We need our KB parser to pass what we need the system to have. So let's just delete this. And let's complete this to this. Oh, great. So I think we can just do it this way. Then this one can fit directly into this. All right, great. So based on this, do you guys have any question? Do you understand what we've done so far, or does it still look like there's a lot of things that you feel missing? And then again, I'm going to ask questions around this. So do you have any question before I ask my question? Okay, the place is officer. Simon, can you hear me? Hello, Simon. Yeah, no, you need to mute your mic, except you're in a place where you cannot respond. I know you can hear me with the icon, but I need to be sure that you can hear me. Oh, I see. Okay, I need somebody who can talk. Not a place where I can talk. Okay, that's fine. Let me see. I don't want to. The ranker part is not clear. Okay, great. We'll get to that part. Samuel, Shailesh, Teka, Udo, Victor, KB parser has to be before the prompt. Yeah, it's before the prompt. Yes, it has to be before the prompt. And I'll explain why, right? So, Lewis, do you have any question? Favor, Akin, do you have any question before I move on?
We're good. We're good. Thank you.
Okay, you're going to explain to me why you're good though, but we'll get there. All right, so Kingsley, the ranker part is not clear. Great. So what does the ranker actually do practically? The goal of the ranker is to take data from the vector DB and then re-rank that based on the embedding. Now, that being said, we need to do one part that I think I omitted. So this is coming. So where do I pass this in? I'm trying to look for the best way to pass that in now. Okay, I think I know how best to pass that in. Let me do that from here. all right, because we also need to supply our ranker the same query itself. Oh, no, that's not what I plan to do. To just do. Yes, this is what I want to do. I'm going to clean this up. It looks like a spider web now. Might be difficult for anyone to understand. So let's on spider web it. Great. Great. All right. I think this looks a bit better. Thinking of moving this to this point. All right, this is better. Okay, all right, so let's start with explaining what the ranker does. So what does the ranker do practically is the query comes in, sanitized, we have the rule, we know who is talking to our system. All right, now that query is sent into an embedding model, converted into a vector embedding, and then passed into the DB. Now, it depends, right? For this case, the vector DB, we assume that the vector DB is a cloud infrastructure vector DB. Again, right, except you're working with financial data where they mandatory decide that your data has to be on-prem, you might be working with your data in the cloud because your company might always want to manage cost at scale, right? Except if your company has money to throw on the VM side, the majority of them will just say, hey, let's go ahead and push. Let's use cloud services like Pinecone and the likes. But if you're not using cloud services, you would have to do the cosine similarity management and tracking yourself. Majority of the open source tools like Weavers and the likes now allow you to be able to do that straight from the library. They abstracted that part, but you'd have to mutually handle that yourself. But let's assume now that you're not handling that yourself, right? So the vector embedding from your query goes into the vector DB. The vector DB does cosine similarity and responds back with a list of vectors and the text associated with those vectors. All right. Now remember that this our system here is a retrieval system. I need to tag that somewhere though. It's a retrieval system. When we want to do our training, ingestion system is a different design entirely, because ingestion system takes a different approach in terms of how you're designing. Are you introducing context? Are you using Elasticsearch to expand how the system is ingesting? What kind of technique are you using? Multi-concurrency, multi-threading, or concurrency with multi-processing? You know, there are a lot of nuances around ingestion, but let's not do ingestion yet. We'll come back to that. Let's go with the easy and then work our way backwards. All right. So your vector DB now returns the result. Your result will usually contain the text, right, and the embedding models that is associated with them together when you did your split, right, with your chunking strategy. Okay, now what does your ranker do? Your ranker takes the text from your the text from your vector DB result and your query, right? So this is still your query. So let's just start that somewhere, and your query, and then passing and then re-ranks them to a particular constant. Let's say you want to see the top 5 or top 3, and then that top 5 or top 3 is what is passed to the LLM. So the LLM does not take in gibberish or non-relevant data. All right. So that's the goal, or that's what the part of the ranker does. That's why we see when the ranker is returning its output, it returns it to the prompt module, right? Because then we then combine that into our system prompt and then pass that to our structured output together into the LLM. Okay, now on what the KB parser is before the prompt. Yes, so what the goal of the KB parser is generally is to actually provide context awareness to the system. Now, the KB parser's knowledge base is usually, again, it can be tied, depending on how you're building the system, it can be tied to the system prompt or the user prompt. The majority of the time, it's usually tied to the system prompt, so the system is very much aware, right, of what it plans to do. So that's what the KB parser does. And again, the KB parser can also be to a particular constant. We can say we are retrieving K number of conversations, right? That is multiple conversation between the user and the AI system so that it has context. So in case the user is asking a follow-up question, it's not done, right? It already knows what it has to do. and then it gets that and then responds with that as well. Okay, what is K-Parser? Okay, I think I just explained K-Parser, and I also explained what K-Parser has to, why it has to be for the prompt. Okay, Akin, what do you think we are missing from our system, right? From we're building an IFRAC system for you start. We can expand that with more capabilities as we go. But what do you think our system is missing?
Sorry about that. It was just actually offline briefly just now. So, but talking offhand, I would imagine everything is there. I can't seem to see anything that is missing. Sorry.
Okay. Hold your thoughts, right?
It's perfect. I think it's perfect like this, but that's just my knowledge. Limited knowledge.
You put limited. Wow, would love to see when your knowledge is unlimited. You build the next AI and just scatter to all Africa. Okay, let me see. KB Parser is kind of RAG for context to prompt. Yes, so it's kind of giving the prompt more context of the conversation that is going on. Right. DF Parser. Can you explain what you mean by DF Parser? Michael, what do you mean by DF Parser? PDF Parser. Okay, no, so we don't need a PDF parser yet. The reason being that this is not an ingestion system, right? This is not an ingestion system. This is practically a retrieval system. There is an ingestion system. I think I should just start that so that we can use that to build on our knowledge as we go. Memory. So memory is from here, right? So this is our memory DB. All right, that's why we have the communication here. I think I did some abstraction here as well, but I'm still waiting for who's going to tell us something is missing here. Like something is missing in this retrieval system. I'm waiting for who's going to break the ice for us. Something is missing from our retrieval system, guys. I need you to think. Something is missing. Our system. There's a lot of things missing practically. A lot of things missing. So if you were to be in an interview and they told you to design this, right, and they said the capabilities that the AI should be aware of the user's conversation as it builds. So let's just build a case in order to portray this, right? Let's assume that everybody in this team is an AI/ML engineer that has been contracted by Central Bank to build one of the governors of Central Bank, or one of the one of the board members of Central Bank. And your role as one of the board members, or your position is to build a particular system in this particular AI system, or to build a retrieval system for their AI system that allows them to be able to chat over policies and then chat over how the commercial banks are reacting to these policies, because data is already fed from somewhere into their DB. All right, great. Now, when they chat with your system, number one, they expect that your system should be aware. They should not come today ask about how fiscal policy is affecting the economy and how banks are reacting, and come back tomorrow asking the same thing, and the AI is responding like it never knew. All right. So then, with this in mind, you have been contracted, and they've asked you to first prepare a system design for them to understand or get a grasp. The technical team have asked you to create a system design for them to get a grasp of what you intend to do and how it intend to work, and how the components are intended to work together. Now, that is what this session is practically about. Our system is still missing vital things to even achieve that. What are we missing? You don't need to so memory. We already have. Okay, I think I already responded to that. Redis. Why do we need Redis?
For session memory.
For session memory. Okay. So why do we have the memory DB? And how much data can Redis hold per session? I need everybody to jump on that question. It's not an Atkins interview, right? It's a general interview. What I mean by memory is like the chat history kind. Exactly. So that's what I'm saying. Right? The chat history kind. something is missing. Memory DB is for chat history. Yeah, but it's not connected. Look at our design favor. It is not connected. Right now, our system seems to be able to write and read. Memory DB is enough for long-term memory. Vector DB is for long-term memory. But again, recall that the goal of our vector DB here, except we want to do the semantic search, the goal of our vector DB here is basically for retrieval purpose from trained data, right? We want to create that much of an isolated system where we know that this is where data. And again, remember that if you're connecting to their system, in this case, we're using the central bank, right? If you're connecting to their system, they're going to create some locks around sensitive data, which means that as the AI engineer, you may not even be able to know what data is loaded into the vector DB. Your own goal is to just plug in and plug out. But the memory DB, you may be able to create structures around that. So we may not be able to have the liberty to use vector DB for our long-term memory for that use case. All right, so what is our system? Our system is missing a lot of things, and I need everybody to think. It's a system design session, all right? Udo, Deborah, what is our system missing? What do you think our system is missing? We should connect let me see. We should connect the memory DB to the prompt module. We should connect the memory DB to the prompt module. Why? Why should we do that? Lewis, go ahead. Why should we do that? That's interesting. Why? I need to hear that. Lewis?
Yeah, so can you hear me?
Yes, I can hear you.
Oh, I mean, you said that at the moment the memory DB is not connected, so I'm just thinking, so for the next query that comes in, when we are passing the whole prompts to the prompts to the LLM, so you should also be aware of the previous questions or related questions or session states. That's what's going on.
Great. All right. Hold it there. I like that. I want to see how many people believe, or what do you guys think about what Lewis just said? What do you guys think about what Lewis just said? Do you concur, or do you feel like that may not be what we should do for making a charter step as the entire context? Abdulsabah, maybe you should unmute your mic and explain. All right, so that I'm a bit clear on what. In the meantime, you guys heard what Lewis said, right?
Yeah, what I meant is like in a general arc system, so there are usually like variables that hold most of the parts that we need. So there's a part that hold the contexts. So we can have a variable for chat history, and then the memory DB will be parsed in a way, and then it will be added as full text, so that the LLM can also get that this is what we've been talking about before. And then when new questions come, it can just join everything together with the context and give you a response.
Great. So you see why I like vocal conversation. They bring a lot of clarity. Mills, what do you think? Levis has said something. Abu Samad has said something, and I think it's taking us somewhere. But Mills, what do you think?
No comments. No comments.
Why do you have no comments?
I'm actually a beginner in this space, so like I'm still trying to understand.
Thing, right? That's the good thing. It's an open mic session. It's an open mic and open thoughts. So, and there's no stupid thoughts. Like there's really no stupid thoughts. The goal of it is that when you engage in this kind of exercise, you even asked to open your mind and share your thought as you think about it. That's why you see me as I'm talking, I'm sharing my thoughts. You see me also get to a point where I'm stuck and I say, oh, what am I going to do here? Like, because you need to think out loud, right, when you do system design. Simon.
Okay, so I just want to say something. I don't know if it's possible, but I think the vector database should also be retrieved by the main DB, the chat DB. So like there should be a connection between the vector database and the memory DB. Yeah.
Why?
Okay. To just I think if there is if there is I don't know, to make it longer, to store the sessions longer, so that it will be persisted to the memory DB, so that like once there is a new, let's say if the user comes back another time and there's a new query that aligns with what someone has queried before, it's sort of retrieves it from the memory DB instead of storing it back into a vector DB. So
I see. Okay. That's also going to be, so we have Lewis' idea, we have your idea, we have Tamad's idea. I can go ahead, unmute your mic, and those things you've been talking about in the chat, you say it, let me hear what you have to say. Akin, can you hear me?
Yeah, I said there are two levels that occurred to me. I'm thinking of maybe session history management, managing that particular. And then there's also the query history management as well. So that once the person issues the first query, modifies it second time, modifies it the third time, the retrieval system should be able to augment its memory, with whatever the new current status is. I think this is just what I'm thinking of.
Okay, so what about the session part? I know that you just spoke about the query part. What about the session part?
Okay, so like if a user comes in, has had a prior experience, maybe like 2 hours earlier or a day earlier, and then the system should be able to recall the user's credentials or whatever. Then the previous experience they had, the previous knowledge queried, and then using that to reflect that this current request by the user aligns with the form or whatever it is, just to manage with the prior engagement to the user.
Beautiful. To be very honest, that was so lovely. I loved hearing that. Right. I don't know why. I think I'm just crazy about engineering, but I love that. Right. Okay. Why do you people like to stay where it's loud when it is your session time? We're going to start assigning AI police for people. Chirag, like, what do you think? Chiamaka, what do you think? Alokam, what do you think? It's not a Akin and the Mills and Lewis session or Absumas, it's a general session. All right. Samuel, what do you think? Olachide, what do you think? Why is Solomon unmuted today? Why is he muted today? Solomon. Is he here? I don't think the man is here. The man is his AI is listening to our call. Okay, so let's start implementing some of the abilities that we've talked about. So number one, I like the session management. So I'm going to actually start with the session management part, right? Because indeed, it's pretty important, right? Very important that session is managed. So how do we know that session is managed, right? Because again, if this user comes in and is asking a question, we cannot just pull from the DB. We can't just pull. We need to track. You need to track him from the session ID to know if he had previous session, and we need to pull information from the DB, right, based on his session ID, and then track his session ID will then be tracked with time. So how do we define how long is a session? All right, how do you define how long is a session? Because these are the questions that they're going to ask you if you're building enterprise rack systems, right? How do you ensure that you're cutting costs? Because the longer or larger the memory, the more expensive the token from your AI, right? So you can't pull everything in the memory. Right now, our system is pulling everything from memory and passing it to the AI. It just says warm-up mode. It doesn't tell us what's actually going on here. We just pull everything and pass it in, and that's a problem. So beautiful recommendation actually is session manager here will make way for all of that. So we're tracking a user session, right? Based on your readback role, we're tracking your session, knowing how long we're connecting, and then managing it based on K. So let's just put this right here and just add this based on K. All right, so what does K mean? I think I explained that earlier. I said K refers to the number of data you are pulling in. So think of K as, depending on the structure, what DB you're using. Right? So if you're using a DB where your memory, each chart is isolated from each other, then K will be ×2. All right. So if you put 6, that means ×2 will be AI agent, AI agent, AI agent, AI agent. Right, ×2, that will be 12. So you're putting 12 chart records from the DB and then passing that into your system. All right, beautiful. Then I love what Lewis said about us connecting our problem. Now, if you look at this, this is our AI response, right? But there's a problem. Our AI response goes to the user, but when it's coming back, nothing. We don't know what's coming back. We know that our readback role goes to the DB, right, and pulls information for the DB, which means if this is a read and write session, but it's reading and writing only what comes in as a query, which means based on our former architecture design, our system only stores what the user says. What the LLM says is lost. So if the user says question like based on chapter 5 of XYZ book, or based on chapter 5 for mathematics, artificial intelligence, all right, what is XYZ or what is ABC? And then comes back and says, all right, so if I do ABC plus EFG, the system doesn't know. The system only recalls the last thing you say. It doesn't know what it responded as, so it cannot flow with the conversation. So to resolve that, we will need to be able to siphon LLM response back into the DB, right? And do that. We're going to do that based on session. So what we are going to do is, let's take this from here, all right, and then let's put it right here. So we know that it goes back into readback, because readback has to be like the same as readback is our safeguard and our control for the system. Then we're going to expand this and then put it here and say user query plus AI response, and then we'll say it's loaded into memory DB. Great. All right. So what are we missing? What else are we missing? What's the time now? Wow, 8:10. Can we catch the user query and response using, oh my God, I think, can we catch the response using memory DB, or it will be a different component? Awesome, Chirag. Now, when it comes to catching user response, right, again, we may not necessarily have to use the DB as a whole. The goal of catching in itself, which is an excellent technique, is to ensure that the system again is optimized for speed. So think about it. Whether we have our DB as a warm-up module, right, before we start doing any query, because we see it at the start of our application, calling DB for every single conversation is expensive. So what technique can we do with catching? We can do this. We can catch every K equals to 4 of every session. Let me break that down. I sent hi to the AI. It responded back with hello. That's one session. Doesn't runnable chat. Doesn't runnable message chat. Okay. Favor, you need to break that down. All right. So I sent hi to the system. It responded back with me, say hello. I responded, what's your name? He responded back with say, I'm Akin AI. Right. I say, how are you, Akin AI? He says, I'm fine, Sam. How's it going? I say, oh, it's going great. We're having AI session of code. AI summer of code. He says, oh, great. I hope everyone is having fun. I say, yes. All right. So that's around K equals to 4, right? K equals to 4 in this case. My response AI, we had 4 conversation. Now we can persist that 4 conversation in the DB, right? And then we can have like 10 conversations and persist 10 in the DB and only catch 4 of that, because it is the most recent. Now, the only downside to that is the AI would not have like extensive memory of previous conversation. But the beauty of it, of that approach again, is that the system is faster. We don't spend time on expensive DB calls. We just pull from Redis and then do whatever we want to do. That's a very good use for Redis. But again, you can't use that in isolation, because again, this is where system designer comes in again, and then we ask ourselves, if we catch the results and the user want to ask extended question, how do we copy that? How do we utilize Redis and also use our Cloud DB? All right. On bearing in mind that Redis will likely be hosted locally, instead of using the Cloud Redis, it will most likely be hosted locally in the system, which means we have to contend with system memory. How large will the system memory be to persist information for how many number of users? 1,000 users persisting their memory in the VM server. Will it survive or will it crash? So again, these are the things we have to wrap your head around as you build applications for AI. Because again, AI in itself is already categorical data, which means it is textual in nature, which again means it bears the capability to exponentially grow as the user have conversation, and bearing in mind that majority of these things is held in memory position by the system. All right, so that being said, awesome one, Chirac. That's a very beautiful idea to bring forward. Okay, anything else we need to add to the system? Or does anybody have any question? Let me start from there, and then we can then work our way backwards. Does anyone have any question? General, do you have any question? Any question? I didn't hear from Solomon throughout the call. I didn't hear from Olajide, right? I've got head on Shailesh. I heard from Lewis. I heard from Fumlayo. I think one time I did hear from Fumlayo. Damilari, this is not a note taker. He came to class with a note taker. That's interesting. Okay. Alokam, I didn't hear from you. All right. So if there are no questions, if I was to delete this whole thing that we did here, can you recreate them? Guys, if I was to delete everything on this screen, can you recreate it? Why am I not getting yes? I was expecting a lot of yes. Oh, can you guys still hear me? Favor, yeah. Favor,
I'm sorry. First of all, can you hear me? Good evening.
Yes, I can hear you loud and clear.
Okay, so I have a question. I was wondering if we are to implement guardrails, apart from the already existing one that the LLM has, but we are to implement guardrails. For example, we are building an AISOC that's like a intelligent knowledge management system that varies from one company to another, but there are certain guardrails that is a reflection of the company's that is building it. So, for example, the company that
I don't know if it's me, but Favor, I'm
did
struggling
something
to
similar
hear.
to that and guardrails.
Favor, your network is breaking. Can you start again? Maybe start from the part where if you're working for a company that is part of their policy. I think that's where I lost you.
Okay, so I was asking if you are to implement guardrails, like how the AI should respond in certain scenarios. For example, if you don't want the AI to respond in political scenarios or take certain sides, or say one religion is better than the other, one tribe is better than the other, you don't want it to be biased. How can you reflect that in guardrails? Where will you set these guardrails? Like at what point of the system will you set the guardrails that it will ensure it behaves in a particular way, or it should not behave in a particular way?
Very good question. I think that will lead me to ask you, should we take one session, not tonight, not tonight, but do we take one session where we do a very deep dive on prompt engineering? I think that would be an interesting session. But I need to know if it's something you guys find like you're very open to, right? We just do a deep dive, right? Beyond just normal, we look at different forms of prompt engineering, the third person approach, we expand on role play and stuff like that. Because the question you are asking in favor is a prompt engineering approach, right? You do that on the prompt engineering level. You can't do that on the engineering level again, because the engineering level is more about systems. For what you want to do, it's more about behavioral control, right? And that has to be on the prompt engineering level. And there are certain ways you need to shape the prompts. There are certain places you need to put it. You can't put it anywhere in a prompt. You have to put it at a specific place for the LLM to need to make sense of it and prioritize it. If not, it's going to count it as information, and as the chart grows, it's going to disregard it. Right? So you can't put it anywhere, number one. Number two, you can't frame it anyhow, or it's going to disregard it again, right? Then number three, it now depends on the model you're using. You can't just use any model for any task. So let's use the example of an LLM that is used by a company and their policies that they refrain from sharing political views, right? You can't use a basic model for that. You need a model that has high reasoning, and also the parameters of that particular model, you need to control it, which means, for example, you might need to drop down the temperature to almost 0. So the LLM is so blunt and very uncreative, right? You need to drop that down. And then you may need to increase the top, right? So that it can stay itself more closely to what your prompt instructs it to do. And all of this approach to policies, you can't put them in the user prompt. You have to put them in the system prompt, and you have to define it in such a way as you may need to follow the third person approach in terms of prompt engineering, right? But all of this is seated more on the prompt engineering side. Does that answer your question?
Yes, it does. Thank you very much.
All right. Okay. Any other person with any question? Now, there's going to be a take-home test. I'm thinking, should I do that? Should I give the test on this call? Well, that would mean that most people might miss it. But you're all going to redesign, create a system design and submit it as an assessment. Right? You're going to design a system. You're going to create a system design, right, and submit it as an assessment for this particular session tonight. Then, when you do that, no, I think I know what I'm going to do for you guys. You will design it and you will build it. Yeah, how does that sound? I think that will now show a reflection of if what you ordered is what you got. I'm going to see the people who usually do what you ordered versus what you got. If you are really going to build what you said you were going to build. All right, so you will create a system design and then you will build that system design, right? So, for example, what we have right here, you need to build it, and I need to see all your modules clear as you mentioned in your design. I need to see the interactions clear, and I need to see very high separation of concern, right? Your system that you build has to be highly testable. It should be testable, and it should also be usable. So, and don't build a dummy system. Build something that if you put it on your GitHub and any employer asks you about it, you can flag the system design as a badge of honor, right? That if you didn't just build, you thought thoroughly about what you wanted to do and then you built it. So that's what we're going to do as a test. I'm going to share that by the weekend. You design the system design and then you're going to build that system design. So should you choose to build a training, an ingestion system for RAG, that's fine. Should you choose to build a retriever for RAG, that's fine. Should you choose to build an agentic system, that's fine, but don't build me a chatbot. Right? It can either be an ingestion system, a retrieval system, or an agentic system. I don't want a chatbot, right? I was speaking somewhere yesterday and I told them an agentic system can be a chatbot, or a chatbot cannot be an agentic system. And it may be a bit confusing, but when you think about it deeply, you get to understand that it's all about the architecture and the design. All right. So any other question? I think we can just close it up for tonight. Do you guys have any question? Is everyone cool with the test? Okay, finally, I'll come. Go ahead, please. You are the much awaited guest. Alakam, you can unmute your mic.
Okay, good evening. Please, can you hear me clearly?
Very clearly.
Very clearly, okay. So I wanted to ask if we are to create like our own questions or the kind of system we want to build, and then design the system like that is supposed to solve the problem for whatever question we're trying to ask. I was thinking, are we going to be the ones that will create that ourselves, or do you want to create for us and create the question and see how each of us try to create the system design for it? So that's my question.
Okay, that's an interesting one. To be in all fairness to you, I would have wanted you guys to do it yourself, but then I don't think of how do I really evaluate you, but I'm not really big on evaluation. I just want to see the effort put in, and I want to see really good effort. But now that you point me in a particular direction, I think what I would do is I would create 3 sets of questions. Don't worry, they won't be too serious. 3 sets of questions, and then you can pick any of the 3 and attempt them. Does that work for everybody? Okay, all right, cool. All right. Anybody, any other questions? Is there something in the chat? If you want to learn more, what textbook or videos would you recommend we should read? I would recommend that you should, there's a system design book I read on really, I check it's been a while, right? But I mean, YouTube, I would have said YouTube is a good place, but again, YouTube is usually a wacky place again. What I would recommend is read case studies. That they are the fastest parts. Read engineering case studies from Netflix. For example, when you think about it, Netflix wrote a case studies recently, maybe not too recent, but they wrote a case study of how they were able to provide their streaming service that is blazing fast, right? So think about it. When you connect to Netflix, every time it is fast, except it's your network. But from Netflix end, it is always fast. And the system design they followed was to ensure that the device that is streaming from the closest server to that particular location that you live in. And to achieve that, they had to ship servers to the home base of ISPs in different countries, right? And then when you stream, you are streaming at 4K originally. But then the system monitors your network. So they have a network monitoring module in your phone when you download the application. Monitors your network. When your network flunks it or drops down in bandwidth and in speed, they switch it to 480p or 720p. And then you continue streaming. And then when it's better, they switch you back up. So to you feel like it's a seamless service. But under the hood, there's been some thought around what should happen and how it should happen. So case studies are a very good way to learn how to properly design systems that scale and how to architect them as they go. All right. Okay. If there are no other questions, I think we'll just call it for tonight. Thank you so much, guys. I was really hoping we'd have to do some coding tonight, but I think this suffices. You've done the coding part earlier, so my goal is to entrench you guys on how to move your brain around systems design thinking and how to drive that forward into solutions that you can actually build. And I think that really makes a lot of sense, given the goal of the program and for everyone as well. All right, so thank you so much, and I hope you do have a wonderful weekend. Good night.